So yesterday we did the probability of one event, so now we're going to be talking about the probability of multiple events. So more than one thing happening. And as you remember from the counting principle, when you have two events occurring, the probability, well, in the counting principle that we did, the number of events multiplies. So with the counting principle, with each event that occurs, we are simply going to multiply the possibilities. Abilities. Multiply possibilities. So the idea here is you have a probability of one event happening, then the next one, then the next one. We simply multiply their probabilities together. So remember, the probability of an event occurring is the number in the event over the total. So if the next event, if you understand what's happening, if the next event, say we have marbles, and we pick a marble out and we put it back, the outcome stays the same. So the probabilities, the total number of outcomes will remain constant. If the item is not replaced, then things are going to change. So if I started out with 15 marbles and I took one and kept it, then I only have 14 to choose from for the second event. So we just have to keep that in mind when we're going through this. So here we are, we have a bag, there are 3 blue marbles, 3 blue, 4 yellow, 2 red, so total that's 9. Total is 9. Now it says they replace it, so that means no matter what, if we have 2 events, the bottom number will always be 9, and we're going to multiply them together. Okay, so what's the probability of picking a yellow marble? Well, that is 4 out of 9. Probability of picking a blue would be 3 out of 9, and we simply just multiplied these two together. So this was yellow, this was blue, and we get 12 out of 81. We don't need to reduce, that's good enough for me. Okay, so same bag of marbles, but the difference here is we do not put the marble back. So what that means is we have 2 events. So we have to do one at a time. So the probability of picking a yellow marble is, for the first event, is 4 out of 9. But I've taken a marble. Okay, so since I've taken a yellow, now I have 3 yellows. We always assume success when we're doing this. So we always assume success. So if we got, because the probability of getting a yellow marble, well, we have to assume we did get a yellow marble. So now we only have 8 marbles left, but blue didn't change, so blue still has 3 blue marbles. So then this is 12 out of 72. Same deal here. In a bag there are 4 peanut butter candies. Wow. 35 caramel candies. I probably screwed that up somehow. It's probably supposed to be 5 or something. And 3 cherry candies. What is the probability of eating a peanut butter candy first and then eating a cherry candy? Okay, we're just to make math easier, we're just going to make this 5. I must have typed it poorly. So total we have 9, 12. Okay, so they're telling me I'm eating it. So if I take a peanut butter candy, so I have the probability of picking a peanut butter candy is 4 out of 12. And then I picked one out and I ate it. So now I only have 3 peanut butter candies. That also changes the total. So the total is, instead of 12, it is now going to be 11. But cherry candies, I didn't eat a cherry candy. I ate a peanut butter candy to start. So 12 out of 132. Okay? Now this kind of event, when you're rolling a die, we can't rip the dots off of a die. So it's always the bottom number will always stay the same because I can't keep one of the dies, one of the sides on the die. So the probability, so we have a die. 1, 2, 3, 4, 5, 6. So there's 6 possibilities. So there's two, we're doing two events. We're doing first, I get a 5, so how many 5s are there? Well, there's 1 5. Then you roll an even number, so how many even numbers are 1, 2, 3? So that would be 3 out of 36. All right, have a good day.